Alright, here's another video about projectile motion. This time when we talk about it, we're going to go over how to approach it when we have an angle attached. Okay, a pretty standard problem is either you have something being launched off a height to land below, or vice versa, shooting something up to something else. Or you have an example where an object leaves an elevation and lands on the same elevation. A classic example of this would be like I have a soccer ball and I kick the soccer ball, okay, at some angle, and it flies through the air and it just lands back on the ground. That's a pretty easy example, okay? So what we can do here, let's assign some values to this. Let's say this is at like 40 degrees. Let's say that we are kicking it, and say like something extreme, 30 meters per second. That's a pretty good kick. Okay. Now we can ask a lot of questions in regards to this. That's all the information given to us. And let's say we want to know how long the ball's in the air. So we want to know T total. All right. Now, I put it as T total for two reasons. Okay. Sometimes people will break these problems into two pieces. So we have the portion here of how long it takes for the ball to get to the top of the arc, and then you have this portion of how long it takes to go from the top of the arc back down to the ground. Okay. In this case, T1 is going to equal T2 because we're landing at the same elevation that the ball started from. However, T1 does not equal T2 if you're landing on a different elevated surface, okay, or below the surface that you started from. All right, but in this case, T1 is going to equal T2. Let's write out a list of givens here. Okay, so my x initial, we can just put that as a 0 meters. X final, we don't know what that is. Okay, my Vx, now this is 30 meters per second at a 40-degree angle. Okay, vector components, right? If you're forgetting how to do that, 30 meters per second, I got a 40-degree angle. Make my triangle, this is Vx. That's my VIY in this case. Okay, so we're going to get this as 30 cosine 40, and AX is going to be 0 meters per second squared. Okay, now my Y, I've got an initial velocity, or let's just start with position. Y initial is going to be 0. My Y final, I don't know how high off the ground it is. Okay. I'm going to approach this. Now when I write out these, okay, I'm going to approach just this left side, all right? Because if I can find out how long it takes to get just to the top of the arc, then I can just times that value by 2 and get my T total. So that's why I say I don't know what my Y final is, because I don't know that height there, all right? My initial velocity in the Y direction is going to be 30 sine 40. My V final in the Y direction, up to this point, that's going to be 0. That's how we know. Okay, that's how we know when we're at the top of the arc, is when it stopped moving in the Y direction. Okay, that's kind of the defining feature. My AY is going to be negative 9.8. A lot of the times I try and make these problems so that I don't have to use a negative acceleration. But in this case you have to, because the ball's going up, gravity's pulling down, something has to be negative. So in this case we've chosen our gravity to be negative. Alright. So here we just want to know T1. Okay. In this case we have a couple of options. I've got a lot of equations I can use. This is the easiest one to solve, in my opinion, for T1. Okay, I use this equation because I can plug in that defining feature. Okay, this is the thing that tells me I've reached the top. So I can either do an equation that involves y final to tell me to state that I'm at the top and ask for how long it takes to get to y final, or I can solve for how long it would take for the velocity to reach 0. Either way works. Since I don't know what y final is at the moment, I kind of want to use this method because I'd have to solve for y final first, but without time, I don't know how I'd really do that easily. Okay, and so here, I'm going to plug in 0 right there, solve for t, and you're going to get negative VIY divided by AY. I'm going to plug in some values, 30 sine 40 per second. That's going to be negative because of that negative. And then I've got negative 9.8 for my acceleration. All right, plug that in. And you're going to look at, let's see, that comes out at 1.97 seconds. All right, but that's only how long it takes for the ball to go from here to here. So I just take that 1.97 seconds, times it by 2 to get t1 plus t2, and you're going to get 3.94 seconds, and that's your answer. Okay, we can extend this problem. Let's say there was a part B and say, well, how high off the ground did the ball get? Now that you know what your T1 is, especially, okay, you know how long it was in the air before it got to the top, you can easily just plug that in to something like this. Our favorite equation, right? Okay, you could plug it into this. My y initial would be 0. Okay, my VIY would be that 30 sine 40. And I would plug in my T1 value. Well, it was in the air 1.97 seconds. And then I've got 1/2 times negative 9.8 times 1.97 squared. Okay, and then you could just solve that out and get your y final. At that point, if you want to go from that y final and solve for t2 just to confirm that it is 1.97 seconds, then you can solve for t2 using this equation. Okay, and when you use that, you just want to make sure you change that acceleration back to a positive value. Okay, so this number, whatever that is, goes there, and put it as a 9.8 because we don't want a negative square root. All right, if you have any questions about this, come in. Love to talk to you about it. This is a pretty standard example. You got at least 2 or 3 questions on your homework that fit this kind of criteria. Hopefully this helps you.